Hey everyone, so the rain has cleared up. It's a beautiful sunny day, so what better weather to learn about some more set theory. So sit back, relax. We're going to learn about some really important concepts in set theory, that is union and intersection. So let's do it. So I've got a pizza in the oven, ready for dinner. Okay, so while that's cooking, we are going to talk about operations which make new sets from old sets. So ways to combine sets to make new sets. And the way we do that is with the union and intersection operators. So let's look at those in a bit more detail.
So let's look at some ways to construct new sets out of old sets. So the first way is to use this union symbol. The union symbol looks like the letter U, so U for union. So let's look at the definition. So this is telling us that the members of the set A union B are coming from the set U. Now let's just imagine that U stands for universe. So it's just the set of all things. So anything you can imagine, you know, bagels, cream cheese, Marissa Tomei, exist in the set U. So the set A union B contains any element X such that X is in A or X is in B. So that's a good thing to remember. There's a really tight connection between the word or and the union. So let's have a look at a Venn diagram, because they're really useful in understanding these concepts. So let's say we have two sets, and we want to know what is in A union B. So whatever's in A union B will be whatever I'm shading now. So it'll be things that are in the set A but not in B, so this region here. It'll be things in both sets, so this region here, and it will be things in the set B as well. The things in the set B that are not in A. So the shaded region contains all the elements which are in either set A or in set B. Okay, let's have a look at the next one. So the next one is intersection. So intersection is symbolized by this sort of upside down U, and I like to think of it as an N, representing the N in intersection. So the elements of the intersection are coming from U, the set of all things, the universe. The set A intersect B is the set of elements X such that X is in A and X is in B. So just like there's a tight connection between or and union, there's a really tight connection between intersection and and. Intersection and and. So to be in the intersection, you need to be in both sets. So A intersect B will be the region containing the elements which are in both sets. So it'll be the region where the sets overlap. So that's what's meant by intersection. Intersection it essentially means overlapping, the overlapping region.
So the most important concepts there are that the union means the total area encompassed by both sets. The intersection, on the other hand, is the area where the two sets overlap. So that's the most important distinction to remember. So let's look at an exercise so we can get super clear on this concept.
Say we've got two intervals, X and Y, and we want to find their union and their intersection. So let's imagine that X and Y are two stores, and this represents the time, their opening hours, the time that they're open. So let's imagine that X and Y are both places that sell my favorite types of dinner. They both sell pizza, let's say. And I don't really care which one I go to. I can go to X or I can go to Y. So this question is asking us, what's the union of X and Y? What are the times that either X or Y are open? And that's really what I care about, because if I don't care about where I get my pizza from for X and Y, that means that I am allowing myself to get the pizza from the union of the two stores. So let's imagine that store X, so this is X, and its opening hours are from 4 to 6. Now we can see that the opening hours do not include 4 itself. So that's what that curvy bracket means. It means that 4 is not included in that interval, but 6 is included. 6 is included because we have the square bracket, which is telling us that 6 is included. Okay, so it's open from, let's say, 4:01 to 6. So let's look at store y. Okay, so the interval that store y is open is at 6, including 6, because we got the square bracket on that boundary, all the way up until 8, and then 8, it is not open at 8 itself. It's not open at 8, so it closes at 7:59, let's say. Okay, so we want to know the union of x and y, so that will be any time either store is open. So we can kind of calculate it just by looking here. The first point of the interval is at 4. It's not at 4, it doesn't include 4, it's an open interval at 4. And then we can go to either store at 5, at 6. At 6 we can actually go to both stores, 7 and 8. So after 6 we have to go to store y, and before 6 we have to go to store x, but we can still go to either store. At 8 itself, we've got an open interval. So we have an open interval from 4 to 8, not including either 4 or 8. So the answer would be 4, 8, surrounded in curved brackets. So these are telling us that 4 and 8 are not included. Okay, let's look at the intersection. So the intersection, let's say that store X serves salad and store Y serves sandwiches, and I can only eat one with the other. I can only have a salad with a sandwich. I can only have a sandwich with a salad. So that means I have to go to both stores. So this is asking us, what's the intersection of X and Y? What are the times when both stores are open? What are the times when the two intervals X and Y overlap? And we can see that's just really one point. The only time where they're both open is at 6 precisely. So we could do an interval like 6 to 6, but that's too many symbols to represent what we are trying to get at. So we could just do the set containing 6. So it's only open, the intersection, the time when both stores are open, there's only 1 minute of an interval, and it's at 6 exactly.
Okay, so those examples involve the combination of just 2 sets, but we can actually combine an unlimited amount of sets using the union and intersection operators. So let's have a look at a more complicated example where we combine more than 2 sets together.
Okay, so now we have a slightly more complicated question. So for each positive integer I, let a of I, so a subscript I, equal the open interval, so not including these boundaries, the open interval between -1/I and 1/I. Okay, so let's deconstruct this and really see what it means. So all we do is we substitute every integer for I. So a1 will be -1/1 to +1/1, which is just -1 to 1. Okay. A2 will be -1/2 to 1/2. A3 will be -1/3 to 1/3, and so on. So the first one is asking us what is the union of A1, A2, and A3. So you can see 3 sets here combined by the union symbol. That's okay, that just means we've got sort of an implicit brackets around this one. So we've got the union of A1 and A2, and then the union of that with A3. So no problem there. Okay, let's draw the number line. Okay, so it seems like the biggest, so all these intervals get smaller and smaller, right? So we go from -1 to 1, then we go -1/2 to 1/2, -1/3 to 1/3. So they're always getting smaller. So our biggest possible interval will be -1 to 1. And it will be the open interval from -1 to 1. Okay, so that will be A1. Then The next one is A2. So actually, let's do the 0. So the next one will be A2. So that will be about here. So it'll be negative a half to a half. And again, these are all open intervals, just as specified by the question. Okay, and then the last one, A3, so that's negative a third, it's about there, to about a positive a third, which is about there. Okay, so that will be A3, and this will be A2. Okay, so now we have, I think, a better understanding. So we want the union. We want the union of A1, A2, and A3. So the union of A1 and A2 and A3 will be the region where any of A1, A2, A3 are active, let's say. So actually, if we look at the structure of this, it sort of goes down in this sort of, let's say, cone shape. A1 encompasses all the other intervals. So A2 is totally contained within A1, A3 is totally contained within A1, A544 is totally contained within A1. So the union of A1, A2, and A3, the union just equates to A1. So anytime A1 is active on this number line, anytime any interval is active on this number line, whether it's A2, A3, A500, A1 is active. So the union of these three things will be just the same thing as A1. Okay, let's look at the intersection. Okay, so again, we are doing the intersection of A1, A2, and A3. So we want the region, the interval, where all three of these are active. So A1 is active, A2 is active, and A3 is active. So if we look at the diagram again, we can see that wherever A3 is active, the two previous ones are also active. So A2 is active and A1 is active. And we can see that pattern holds for any number, whatever the number is. Okay, so the intersection of A1, A2, and A3 will be the region where all three of these are active. Because the interval from negative a third to a third is contained within the interval negative a half to a half and negative 1 to 1. Okay, so the intersection, the region where all three of them are active, is A3. Okay, now you might be wondering what this symbol is here. So this symbol is just a sort of generalization of this symbol here. So what this is saying is it's saying take the union, so we've got the big U for union, take the union of A1, A2, A3, A4, A5, all the way up to infinity. So you could imagine it as A1 union, A2 union, blah, 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 all the way up to infinity. And this is just the intersection version of that. So this would be A1 intersect A2 intersect blah, 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 all the way up to A infinity. Okay, so the answer to C is just going to be the same as the answer to A. Now, why is that? Because A1 is always going to be the biggest interval. So to get the union of all these intervals, all we need to do is take the biggest interval. And the biggest interval contains all the other intervals, right? Because A1 contains all the other intervals. Okay, so the answer to that will just be the same as A, so it'll be A1. Okay, now we find the intersection version of that. Well, that's kind of the reverse. So if you notice the pattern of this diagram, as the numbers get higher and higher, as I gets higher and higher, the intervals get smaller and smaller, and they get closer and closer and closer to 0 from either side, right? They get closer and closer and closer to 0. So if we're looking at a 5000, it will be the interval from negative 1/5000th to positive 1/5000th. So it'll be sort of more and more and more, as these numbers go up and up and up, the interval will be more and more tightly wrapped around 0. So the intersection of all those intervals, all the way up to infinity, will be the only number which is contained within all of those intervals. The only number contained within all those intervals. Okay, so as I gets closer and closer and closer to infinity, the interval a of I gets closer and closer to wrapping around 0. So if there's the number line 0, it gets closer and closer to 0. Okay, so the only number which is common to every set A1 to A infinity is 0. So the only thing that would be in their intersection is the set containing 0. The set containing 0.
Okay, so I think this pizza is looking just about ready. So let's take it out. Okay, so I'm gonna tuck into this pizza. Let me know if you got any questions, put them in the comments, and I will see you next time. Thanks for watching, everyone. Please remember to like, subscribe, hit the notification bell, support the channel so I can continue bringing you more great content.